After many years and suffering, signals are finally coming to Angular. Wait, wrong video. After a lot of effort and hard work, signals are finally coming to Tailwind. Wait, shoot, wrong video again. Signals are coming to JavaScript. If you're not familiar with signals, we're going to go over them in a bit. It's a really cool primitive for tracking data in your applications, so much so that they've been adopted by Angular. They're being adopted in a new plugin by Tailwind. But the thing we're here to talk about today is certainly not Angular or Tailwind. It's JavaScript. And we finally have a real and honestly pretty promising proposal for getting signals in JS itself. Let's take a look at the proposal and how we got here. First, when I was Google searching signals JavaScript, this happened, and I thought it was hilarious, and I wanted to show it. When you Google search for signals in JavaScript, Solid comes up, which is a framework you might have heard of. It looks and feels a lot like React, but it is signals-based instead of reaction, like re-rendering based. So it's way, way more performant. Solid regularly wins like every performance benchmark, and their signals stuff is a big part of how they were able to do that. I also want to make sure it's known I wasn't just trolling with the Tailwind thing. This is something I plan on covering. The video probably won't be live before the general JS signals one, but signals for Tailwind video coming soon. What we're here to talk about today is the TC39 proposal for signals, written by Eisenberg Effect. At least this blog post is. He's one of the big advocates. This is the actual proposal. There's a bunch of stuff in it. It's currently in stage 0, so it's very, very early. Like we're discussing what it even should look like right now. But the contributor list is a really cool set of people. It includes little Daniel Ehrenberg, who is a major contributor to TC39, works at Bloomberg, and is regularly involved in these types of things. But as we go through this list, there's even more interesting people. We have Dominic, who is one of the original React core team members, and now he works at Vercel on Svelte. Yes, one of the React team moved to Vercel, not to work on React, but to work on Svelte, which I think is awesome. We have Eisenberg Effect, who is one of the classic modern web architects and web standards guys who wrote the blog post we'll be reading. A bunch of other people like Nullvox Populi. I forgot what they do, but they've popped up on so much shit that I am positive they are very, very productive and involved in these things. We got another interesting one, Michael Westrate. He's the creator of MobX, which is one of the first more signal-based solutions for state management in React. For a long time, we were in the Redux versus MobX wars. And in a lot of ways, he arguably won. Even if MobX isn't more popular, the patterns that he introduced have taken over so many things. He also introduced stuff like Immer that is essential for modern web. I believe he's currently working at Meta, but I might be wrong on that. We also have Patrick.js, everyone's favorite everything developer, the guy who accidentally killed NPM. Check out my video for that if you already haven't seen it. And so many more awesome names, including but not limited to Ben Lesh, who is the creator of RxJS, which kind of standardized the idea of signals in JavaScript. Awesome crew of people. Check out all of them. They're all within some of my favorite devs. I'm actually amazed how many dope people are involved in that list. But we need to understand signals before we go any further. We're minutes in and haven't actually talked about them yet. So, in August of last year, I mentioned that I wanted to begin pursuing a potential standard for signals in TC39. Today, I'm happy to share that a V0 draft of such a proposal is publicly available, along with a spec-compliant polyfill. This is really cool. This means you can start using it today, and it will be polyfilled to work the way browsers currently work. There's also a disclaimer up here that it's a preview of an in-progress proposal and could change at any time. Don't use this in production. Don't challenge me. I swear, every time I see this, it makes me want to use it in production more. It's like the do not use or you will be fired in React. It's like that you're just telling me I should use this, or at least making me want to. What are signals, though? We haven't even talked about that part. A signal is a data type that enables one-way data flow by modeling cells of state and computations derived from other state and computations. This, if you're a React dev, might sound kind of familiar, but usually this is with components, where you have the root component at the top, and it passes things down, but you can't really go back up. And that's the magic of React, is the one-way data tree. The reason that this is so valuable is it makes debugging and understanding your application's flows significantly easier. If you don't have things going up and down constantly, you have to trace these really crazy data trails across your application. React does that not just with data, but with the actual application and React component modeling. So your whole UI has that top to bottom approach. It makes debugging easier. It makes reasoning about your logic easier. It makes compiling it to be more efficient easier. It makes a lot of things easier if you don't allow for data to go two different directions. Like imagine a component that could pass props to its parent. It makes things way more complex, and that complexity has been the default of the web for a long time. React challenged that for UI frameworks. Signals is challenging that for state and data across all JavaScript applications. The state and computations form an acyclic graph, where each node has other nodes that derive state from its value, the sinks, and or that contribute state to its value, which are sources. A node may also be tracked as clean or dirty. What does this all mean? Let's take a simple example. Imagine we have a counter we want to track. We can represent that as state. Const counter equals new signal.state 0. We can read the current value with get. So console log counter.get, this will log out 0. Cool. And now we can change the value with set. Counter.set 1, and now when we log it, we get the new value. Now let's imagine we want to have another signal that indicates whether our counter holds an even number or not. Const is even equals new signal.computed, and in here, counter.get and 1 or 0. This will now give you a new signal of is even that will change whenever counter.get changes. And here's the magic of signals, is that the change here, because if counter gets changed, the value of counter.get is now different. And these signal computations are smart enough to propagate those changes. Because when you call counter.get inside of a signal computation, it knows to recompute this signal. So this signal is dependent on this one. So when this one changes, and now this fires. Computations aren't writable, but we can always read their latest value. So you can't write here either. That's the important thing. You can't do isEven.set. You can only get it because it's a computed value. It's effectively read only. Console.log isEven get false, counter.set. Then when we log it again, it's true. In the above example, isEven is a sink of counter, and counter is a source of isEven. Good shit. We can add another computation that provides the parity of our counter. Here's a fun one. We have parity, which will say even or odd as a string, depending what the value here is. So we call isEven.get, and then it's even if it's true, and odd if it's false. Again, by calling this isEven.get in here, this signal primitive knows that whenever this changes, it needs to recompute this whole thing and change the results of this guy. So now we have parity sourcing isEven, and isEven is a sink of parity. We can change the original counter, and its state will flow unidirectionally to parity. Starting to see how valuable this is. Just like React components, you have a component at the bottom and you can wrap and wrap and wrap. But when that one component in the middle changes, everything's handled. This is that for your data. It's so powerful to have variables where when things change within them, anything depending on them also changes accordingly. Instead of like, another way to think of this, if I just open up some crappy JavaScript here, something we've all seen before is like const x equals 2, const doubled equals x times 2. What if this is in const? What if it's let? And I do x plus 5 or x plus 4. X equals x plus 4. Doubled is still going to be a different number because doubled was created at this point in time. So there's no way to change x such that doubled also updates by default. The magic of this new model is that if we make this a sink and then we have other things that are computed off of it, one change will persist through all of the other signals that have been bound. This is very, very powerful stuff. We're already getting a really good question, which is, this is valuable, but is it valuable enough to be on the web platform? I'll make the argument of yes, not just because everyone should be using this and the polyfills aren't good enough or something like that. Specifically because if this is introduced in the browser, there are a lot of optimizations the browser can do to make it really, really efficient and really performant. And that's what I'm excited about with this being in the browser, is the potential of this being really, really fucking fast. It's already pretty fast, but if the optimization's happening where like memory assignments aren't being made where they're not necessary and such, and everything's computed on the fly, whew, this can fly. Everything we've done so far seems like it could be done through normal function composition, but if implemented that way, without signals, there would be no source or sink graphs behind the scenes. So, why do we want this graph? What's it doing for us? Recall that I mentioned signals can be clean or dirty. When we change the value of counter, it becomes dirty. Because we have a graph relationship, we can then mark all of the sinks of counter dirty as well, and all of the sinks that those have as well, and so on and so forth. This is where that propagation becomes magic, the ability to identify which things need to be changed and just change them all synchronously as a result of that initial change. Magic, and makes your data update model much easier. There's an important detail to understand here. The signal algorithm is not a push model. Making a change to counter does not eagerly push out an update to the value of isEven and then via the graph an update to parity. It is also not a pure pull model. This is an important thing. It's not just going to force everything to be in the updated state, and it's also not going to recompute every time you call it. It's somewhere in between. Reading the value of parity doesn't always compute the value of parity or isEven. Rather, when counter changes, it pushes only the change in the dirty flag through the graph. Any potential recomputation is delayed until a specific signal's value is explicitly pulled. Really cool stuff. We call this a push then pull model. So by marking everything as dirty, like right here, we're not using doubled for anything. So technically, it never actually has to compute this value. It doesn't know what double is. But if we wanted to use this by console.log doubled, now it's actually going to do the compute. It's not going to do the compute here where we assign it. It's going to do the compute here where we actually call it. And then when we change it here to x equals x plus 4, only this has changed. The things that it's dependent on haven't changed until we use them. Obviously, this would be like double.get instead, and we'd have all the signal syntax and everything. But the point is that the actual computation here, the actual work being done after the change, only occurs if and when the thing that it's dependent on is being consumed. It's very lazy, which is a good thing. Lazy, thank you to ZCBQG. Cool. Thank you for pointing out that it is lazy, because that is a very important way to describe it. It is lazily evaluated because we don't need to do this compute unless we know we actually need the values. There are a number of advantages that arise out of combining an acyclic graph data structure with a push-then-pull algorithm. Here's a few. Signal.computed is automatically memoized. If the source value hasn't changed, there's no need to recompute. That's really cool. There's no idea of like a memo, because we don't need one because things are lazy anyways. Unneeded values aren't recomputed even when sources change. If a computation is dirty but nothing reads its value, then no recomputation occurs. False or over-updating can be avoided. For example, if we change counter from 2 to 4, yes, it is dirty. But when we pull the value of parity, its computation will not need to rerun because isEven, once pulled, will return the same value for 4 as it did for 2. That's a really cool point I hadn't thought of actually, which is that with this chain, where we have isEven, if you assign a new value such that isEven needs to recompute to be sure it's still the same, as long as the result's the same, you don't have to rerun this one after. That's a really cool thing I hadn't thought about there. That is a good point. We can also be notified when signals become dirty and choose how to react. Also very useful. You can put listeners on all of these things. These characteristics turn out to be very important when efficiently updating user interfaces. To see how, we can introduce a fictional effect function that will invoke some action when one of its sources becomes dirty. For example, we could update a text node in the DOM with the parity. So here we have an effect. Everyone's favorite. I know us React devs get triggered when we hear this word, but it doesn't have to be that complex, I promise. So here we have node.textContent equals parity.get. Since we put this in an effect, now whatever functionality we put in here reruns whenever this signal's response changes. So if we switched from 2 to 4, it's not actually going to rerun. But if we change it from 2 to 3, it will actually rerun and it will update the text content. So the first time this runs, the node's text is updated with odd because the default value is 1, so it's odd. The effect watches the callback source, parity, for dirty changes. Now we set counter to 2. This dirties the counter graph, which means that this needs to rerun. And this time when it reruns, it sees that this is different. So it actually sets this value this time. But if parity.get doesn't respond differently, then it's not going to trigger all of its dependencies. So we see here counter.set 4, since this results in parity having the same answer because the isEven check before it has the same answer, this never gets run again. The scheduler begins to reevaluate the effect callback by pulling parity. Parity begins to evaluate by pulling isEven. isEven pulls counter, resulting in the same value for isEven as before. isEven is marked clean. Because isEven is clean, parity is marked clean. And because parity is marked clean, the effect doesn't run and the text is unaffected. Nice and easy. Hopefully this brings some clarity to what a signal is, an understanding of the significance of the combination of the acyclic source and sync graph with its push-then-pull algo. I would say so. So who's been working on this? Late in 2023, I partnered with Daniel Ehrenberg, Ben Lesh, and Dominic Ganaway to try and round up as many Signal library authors and maintainers of front-end frameworks as we could. You picked a good group. Anyone who expressed an interest was invited to help us to begin exploring the feasibility of signals as a standard. We started with a survey of questions and one-on-one interviews, looking for common themes, ideas, use cases, semantics, etc. We didn't know whether there was even a common model to be found. That's another scary point, because everyone's implemented signals in their own weird, chaotic ways. I'm pumped that they were able to find something. As they say here, to our delight, we discovered that there was quite a bit of agreement from the start. Over the last 6 to 7 months, detail after detail was poured over, attempting to move from general agreement to the specifics of data structures, algorithms, and an initial API. You may recognize a number of the libraries and frameworks that have provided design input at various times throughout the process so far. Angular, Bubble, Ember, Fast, MobX, Preact, Quick, RxJS, Solid, Starbeam, Svelte, Vue, Wiz, and more. These are all the frameworks that are considering signals or already have them. Not a bad list. Speaking of which, it is quite a list. And I can honestly say, looking back at my own work in web standards over the last 10 years, this is one of the most amazing collaborations I've had the honor to be a part of. It's truly a special group of people with exactly the type of collaborative and collective experience that we need to continue to move the web forward. Important, if we miss your library or framework, there's still plenty of opportunities to get involved. Nothing is set in stone. We're still at the beginning of this process. Scroll down to the section titled, How Can I Get Involved in the Proposal to learn more. Good call out. So what's in this proposal? The proposal on GitHub includes backgrounds, motivations, design goals, FAQ, proposed API for creating both state and computed signals, proposed API for watching the signals, various additional proposed utility APIs, such as things for introspection, a detailed description of the various signal algorithms, as well as a spec-compliant polyfill covering all the proposed APIs. So this isn't just a proposal, this is a thing you can go use today. Interesting that their proposal does not include an effect API, since such APIs are often deeply integrated with rendering and batch strategies that are highly framework and library dependent. Very good call out here. A blank, pocket, boring standard effect would need very different implementations for different frameworks depending on how and where they re-render things, so it doesn't surprise me that they didn't make it in, like they called that out here. However, the proposal does seek to define a set of primitives and utilities that library authors can use to implement their own effects. On that note, the proposal is designed in such a way as to recognize that there are two broad categories of signal users, application devs and library framework infra devs. Thank you for calling this out early. This is a thing I've been shouting about for a while, which is that the experience of these two groups varies so widely, even within well-loved tools. I obviously am a huge TypeScript advocate. I've been pushing TypeScript forever, but I've done that largely as an app dev. Now that I'm working more on libraries, I see why people hate TypeScript, because getting all of your types right can not only be its own massively difficult challenge while building a library or framework, it also can force you into certain directions with your code that you might not have gone into otherwise. I know I'm far from the only library dev that's had to make significant changes to their APIs and their SDKs just to make sure that their stuff can be made type safe with TypeScript. So these things are very influential on both of these sides, and it's not often enough that this is called out early in this way, because the needs and goals and interests of these groups vary wildly. So making sure both are happy, very important. APIs that are intended to be used by application devs are exposed directly from the Signal namespace. These include signal.state and signal.computed. APIs which should rarely, if ever, be used in application code and are more likely to involve subtle handling, typically at the infra level and layer, are exposed through the signal.subtle namespace. I actually like that. I'm not sure if subtle's a word that is easily enough translated would be my big concern, is like internationalization for this. Like this word might not communicate to non-native English speakers well enough what it's for. That's my only concern here, but I do actually really like the use of subtle for this. And also that it's lowercase when everything else is uppercase. These include things like signal.subtle.watcher, as well as signal.subtle.untrack, as well as the introspection APIs. Oh, crypto.subtle. So this is already a thing. Fun. This blog post is really useful. Normally I would skip an ad, but Rob and crew are killing it with this. So if you're interested in a web component engineering course, check that out. Link is in the description for the blog post and you can find this in there. Y'all know I'm the worst place to learn about web components because I just don't think they're good. But if you want to figure out more about them, this is a good place to do it. Anyways, as an app dev, how do I use signals? Many of today's popular component and rendering frameworks are already using signals. Over the coming months, we hope that framework maintainers will experiment with re-platforming their systems on top of this signals proposal, providing feedback along the way, and helping us prove out whether it is possible to leverage a potential signals standard. If this were to work out, many app devs would use signals through their chosen component frameworks. Their patterns wouldn't change. However, their frameworks would then be more interoperable, like reactive data interoperability. Imagine that like you write React code and then you have a Svelte component or a solid component and it can use the exact same state model and the exact same update layer as your React code is using. That's really cool. Exciting opportunities there. It's also smaller because signals are built in and don't need to ship JS. At least if this ships, it will be the case. And hopefully faster because native signals as part of the JS runtime have the opportunity to optimize a ton of stuff. Library authors would then be able to write code using signals that works natively with any component or rendering library that understands the standard, reducing the fragmentation in the web ecosystem. Application devs would be able to build model and state layers that are decoupled from their current rendering technologies, giving them more architectural flexibility and the ability to experiment with and evolve their view layer without rewriting the entire application. Don't MVC this for me, man. We were agreeing. Don't use this as a way to encourage MVC. So let's say you're a dev that wants to create libraries using signals, or who wants to build apps using them instead. What would this look like? Well, we've seen a bit of it already when I explained the basics of signals through the signal state and computed APIs above. These are the two primary APIs that an application developer would use, if not using them indirectly through a frameworks API instead. They can be used by themselves to represent standalone reactive state and computations, or in combination with other JS constructs like classes. Here's a counter class that uses a signal to represent its internal state. No, what part of why I love signals is they help FP. Don't force OOP into here. Cool. Well, it works. It does what it's supposed to. You can still do dependence and shit. So cool. Ugh. One particular nice way to use signals is in combination with decorators. We can create an @signal decorator that turns an accessor into a signal as follows. Export function signal target. Const get is target. We return the get call this the get, set, and init. And when you init, it makes a signal. So now we have this helper signal decorator that we can just put over this signal accessor value 0. And now this has just magically become a signal. My issue here is like this code isn't complex enough that I'd want to abstract it, but cool that you can. Weird, but cool. There are many more ways to use signals, but hopefully these examples provide a good starting point for those who want to experiment at this state. This is a cool call out. That setting on a getter +1, like this, where we add 1 and then we set that this could cause an infinite state and an infinite loop when used within a computed or an effect. The reason for that would be if this.value.set is part of something that is running because this.value.get changed, this could loop really rough. This does not cause a problem in the current proposals computed, nor does it cause a problem in the effect example demonstrated below. Should it cause a loop though, or should it throw? What should be the behavior? This is an example of the many types of details that need to be worked through in order to standardize an API like this. I like this callout actually. At first I was like, I don't agree with this being supported necessarily, but the callout that he's bringing this up specifically so we can have conversations about it and how it should work. This is a very responsible proposal where it's very considerate of the reality of the web dev world and not just trying to be like, here's how we're doing this now. I like this a lot, and I hope more proposals are written this well in the future. Most have been pretty good thus far, but this is dope. So how do library devs integrate these things? We hope that the maintainers of Vue and component libraries will experiment with integrating this proposal as well as those who create state management and data-related libraries. A first integration step would be to update the library signals to use signal.state and signal.computed internally instead of the current library-specific implementations. Of course, this isn't enough. A common next step would be to update any effect or equivalent infra. As I mentioned above, the proposal does not provide an effect implementation. Our research showed this was too connected to the details of rendering and batching to standardize at this point. Rather, the signal.subtle namespace provides the primitives that a framework can use to build its own effects. Let's take a look at implementing a simple effect function that batches updates on the microtask queue. Let needs in queue equals true, const w, new signal subtle watcher. If needs in queue, false, queue microtask. I don't want to read microtask code. I'm not paid enough for this shit. I'm sorry. If these are the types of things you're interested in, you have an awesome blog post to go read about it. That's not the basics. Once you're into microtasks, we're not in basics land anymore. One other fun API is subtle untrack helper. This function takes a callback to execute and it ensures the signals read within the callback will not be tracked. I feel the need to remind readers this is a namespace that's designated for APIs that should be used with care and mostly by frameworks or in for authors. Using this incorrectly will totally break your graph and result in things that are impossible to track. So yeah. With that said, let's look at a legitimate use of this API. Many Vue frameworks have a way to render a list of items. Typically, you pass the framework an array and a template or fragment of HTML that it should render for each item in the array. As an app dev, you want any interaction with the array to be tracked by the data reactivity system so that your list's rendered output will stay in sync with your data. But what about the framework itself? It must access the array in order to render it. If the framework's access of the array were tracked by the dependency system, that would create all sorts of unnecessary connections in the graph, leading to false or over updating. So imagine you have a list with items in it and you change one of the items in that list. The whole list now has to re-render. This is already kind of the case in React. That's why we have keys to identify which things you should and shouldn't actually do the re-render for. But every framework has their different way of handling it. And you might just want to untrack the list and build your own tracking for every item in the list, kind of like how something like Solid would do it. So that's what I'm sure they're going to propose here. Let's see. If the framework's access of the array were tracked, yep, it leads to the false or over updating. But also, weird bugs. This is where lots of weird bugs tend to crop up, even in React. That's why keys are so important, because if you do them wrong, everything breaks. The Signal Subtle Untrack API provides the library author with a simple way of handling this challenge. As an example, let's look at a small bit of code from Solid that renders arrays. Funny that got called out already. Which I've slightly modified to use the proposed standard. We won't look at the whole implementation. I've cut most of the code out for simplicity. Hopefully, looking at the high level will help explain the use case. Hopefully. Let's take a look. Map array. Items, mapped, length. Cool. Return new items, which is list or empty array. I and j, which are all the new things we just defined. New length is new items.length. And now we're going to go through and untrack the existing stuff. Nothing in the following callback will be tracked. We don't want our framework's rendering work to be affecting the signals graph. Cool. So now we have this list, and I'm assuming I won't assume anything. Let's just read how it works first. So now we're doing all the work in here in order to make sure that any work we do and any values we access aren't going to automatically be tracked unless we want them to be. So we have an early escape for empty arrays. We have a fast path for new creations. And then we just read otherwise. Cool. Even though I've eluded, I'm not even pretending I know what that word's supposed to be. Even though I've skipped the bulk of Solid's algorithm, you can see how the main body of work is done within an untracked block of code that accesses the array. There are additional APIs within the signal.subtle namespace, which you can explore at your leisure. Hopefully the above example helps to demonstrate the kinds of scenarios this part of the proposal is designed for. I think that makes sense. Specifically the idea that the framework rendering shouldn't trigger things in the graph. That part mostly makes sense. But I wish I could see something here that is actually a signal to use to follow the data trail. I'm sure Ryan Carniato will have a lot smarter of things to say with this than I do. Here are the instructions on how to get involved. If you're interested, check the link in the description to this article to learn more. I'm not going to cover this directly, but it is really useful, and it's awesome they're calling out the need for help, even with things like testing or porting other Signal implementations, even if just examples. A lot of opportunity for people who are really interested in this proposal to get involved. Good stuff. So what's next? We're still at the beginning of this effort. In the next few weeks, Daniel and Jaden from Google and Bloomberg respectively will bring the proposal before TC39, seeking stage 1. Stage 1 means that the proposal is under consideration. So right now, TC39 isn't actually considering this proposal, it's just in work. Once it hits stage 1, that means they're actually thinking about it as a formal group. And as he says, they're not even there yet. You think of Signals as being at stage 0, the earliest of the early. Out of presenting at TC39, we'll continue to evolve the proposal based on feedback from that meeting and in line with what we hear from folks who get involved through GitHub. Our approach is to take things slow and to provide ideas out through prototyping. We want to make sure we don't standardize something that no one can use. Woof. Like web components? I'm sorry, I have to sneak a web component dig in here. I was nice earlier. We'll need your help to achieve this. With your contributions as described above, we believe we'll be able to refine this proposal and make it suitable for all. I believe a Signal standard has tremendous potential for JavaScript and for the web. It's been exciting to work with such a great set of folks from the industry who are deeply invested in reactive systems. Here's to more future collaboration and a better web for all. That was a post. I had high hopes, but honestly, I'm even more excited now that I've read that. Just seeing who's involved and how much they're considering both app devs and framework authors means the future of Signals is bright. Let me know what you guys think in the comments. Are you excited or is this just overhyped madness? And until next time, peace nerds.